Hello, everybody, and happy Friday. I am sorry I am not with you in real time today. I had an appointment today, and so I had to take the day off from school. So I made this video for you so that we are not losing instruction and we are going to keep moving forward ahead with our learning. So, what I want you to do to start off is open up this Jamboard. It was posted in Google Classroom. So it's called Logical Reasoning, and everything that you're going to need for class today is on this Jamboard. So open this up, pause the video if you need to while you're getting this opened up if you haven't opened it yet. And once you get it open, go ahead and start on the warm up. You're going to answer these two questions. If it's possible, name the congruent triangles and give the congruence shortcut. If it's not possible, tell why. So again, pause the video while you work on this and get the Jamboard open. And we're going to be doing some guided notes today. When you have the warm up finished, unpause the video to check your answer. So let's look at number one. So for number one, we have triangle TOP, and we want to know what is it congruent to if we can name it. So I see that I have a side and I have an angle O congruent to angle A. I also know that I have a vertical angle in here. So angle OPT is congruent to angle APZ. Did you see what I did there? I used corresponding parts. So since I started with OPT, O corresponds with APZ. And so now I have a side, an angle, and an angle. Look at the order. Okay, so I have my side, my angle with 2 tick marks, my angle with 1. Over here, I have a side, an angle, an angle. Again, I have my side, my angle with 2 tick marks, and then my vertical angle that I wrote in. So let's write down our congruence statement here, or completed for my triangle. So T corresponds with angle Z. So this is going to be triangle Z. O is my next one. O corresponds with A. And then the last letter has to be P. And I know this because of side, angle, angle, or you could write angle, angle, side. Now let's check out number two. Number two has triangle TRP is congruent to, how would we say this one? So let's look at for triangle TRP. So I have a side with 1 tick mark, an angle, and then I have this shared side with 2 tick marks on it to mark congruence. And then if I look at my other triangle, RAP, I have a side with 1 tick mark, my angle, and then the side with 2 tick marks. So I was using side, angle, side to prove this. And again, we're going in order. So now let's check out our corresponding parts. So I'm starting with T. T doesn't have an angle that is marked, and it is next to the side with 1 tick mark. So that looks like that would be angle A. Sorry, side. Yeah, angle A. Sorry, my fault. Angle A. And then R, point R, is this angle right here. It's going to correspond with P. So A, excuse me, AP. And then P over here will correspond with R. Now that could be a little bit confusing. And so what might be helpful for this one is to draw the triangle out. So if you draw it out and you put TRP, and we're not even going to really change its orientation, we're just going to redraw it. And then I'm going to draw triangle PAR. That's R, A, P. And then if I go through and I mark all of my congruence statements on here, or my markings, then I can see, especially when we're reusing those vertices, that can get a little bit confusing. So TRP, and then over here we do APR for that one. And again, that is by side, angle, side. Everyone, please advance to slide 2. So what I did was I tried to put in some information on here so that you didn't have quite so much that you needed to type. And so we're going to be looking at logical reasoning forms. We've done a little bit of this when we've talked about converse statements, but we haven't really talked about inverse or contrapositive. So I'm going to have you include some things on here. So you can either do sticky notes or you can write it out. That's up to you. I just don't want you to spend an enormous amount of time on this piece, trying to get those things in here. So when we talk about a statement, and we have two parts of it, we have like the if and the then, right? So here we have the if, the then, if, then, in every single one. If, then, if, then. And in all of these statements, we have the same components, but they're in different orders. So the way that we think about this, we use a couple of variables for this. So with our statements, we use P and Q. So for a regular statement, it's if P, then Q. That arrow signifies then. Okay, so that's how we would write that. So over here, we're going to write this in, if P, then Q. And this is just the regular statement. That's how it gets started. So when I look at this, my P is if two angles are vertical angles. If two angles are vertical angles, and I'm going to double underline my Q, then they are congruent. Is that a true statement? Yes, this is true. So we are going to write true over here. That is true. Now think about this, my P, and this stays my P throughout. If two angles are vertical angles, that's my P. My Q is my then right here. But now look what happens in my converse. So now this has if two angles are congruent. That was my Q statement. So I'm going to double underline that. You could also highlight it a different color. We could, the highlight on here is not very great. Let's try by doing the green like that for my Q. So if two angles are congruent, then, and let's do red. No, that is red. Let's do blue. Then they are vertical angles. So we'll make our P the blue here. So what I did here for this one, that means that I went Q, then P. I reversed my statements. So if two angles are congruent, then they are vertical angles. Is this true? Not necessarily, because we can have angles that are congruent that are not vertical angles. We could have two supplementary angles that would be 90 degrees each, but they would not be vertical angles. So for this one, for this particular statement, this is false. And the key for this is we are switching the if and the then. So we're going to switch the if and the then. All right, let's look at the converse now. So this starts, if two angles are not vertical angles. Uh-oh, there's a not in there. Okay, so let's go back. So vertical angles, it's talking about them being vertical angles, so it's P, but it has that not there. And so since it has that, I'm going to underline it with blue because it's still that P statement, but they've negated the P statement. And the way that we represent that is one single squiggle not P, then they are not congruent. See, we've got that not there again. Okay, so then they are not congruent. So not P, then not Q. And the rule for this one is that you negate both statements. So if two angles are not vertical angles, then they are not congruent. Well, we know that there are angles that are not vertical angles that still could be congruent. So this is also false. Now, the last type of statement that we have is called a contrapositive. And this says, and we've got that not in there again. So if two angles are not congruent, then they are not vertical angles. So remember, with our inverse, we're negating. With our contrapositive, we are negating. Okay. And so with this one, we've got if two angles are not congruent. So go back to your original statement. If two angles, that's vertical angles. If here the second statement, the Q is what's telling me about them being congruent. So I'm going to underline that in green because that is my Q, but it's my not Q. So again, remember we're going to negate that. So not Q, then, so my next statement must be P, but it's got that not there also. So they are not vertical angles. So not Q, then not P. So for this one, the rule is we reverse and negate the two parts. So when we talk about reversing and negating, we're talking about from the original statement. So the rule here is we reverse and negate both parts. Now let's think about, is this one true or false? If two angles are not congruent, then they are not vertical angles. That is true. If they're not congruent, they cannot be vertical angles. Go with me to slide 3. Again, if you need more time, pause the video. On slide 3, we are going to tell if each statement is converse, inverse, or contrapositive. Okay, so we're going to tell if each statement is converse, inverse, or contrapositive. So we start off, we've got our original statement is if a triangle is a right angle, then it has a 90-degree angle. That's our original statement. And we're not telling if these are true or false right now. We're just telling what they are, like if it's converse, inverse, or contrapositive. Okay, so we have our original statement. So I'm going to start off by highlighting, and my P is if a triangle is a right triangle. That's my P. And you can change your colors if you want to, or change it up. My Q is it has a 90-degree angle. So that's my Q. So now I'm going to come down here. My first statement is if a triangle has a 90-degree angle, that's my Q. So this is if Q, then it must be P, then it is a right triangle. That is my P. And so if it's Q and then P, then our answer is converse. Our second problem here, if a triangle is not a right triangle. Okay, so the right triangle part was my P. So if a triangle is not a right triangle, and remember that's got that not there. So we're doing, this one is not P, then it does not have a 90-degree angle. So not P, then not Q. So we're going back to the original statement, and when we just negate the statements, making them not, then our answer is inverse. This is the inverse of the statement. And then our last one is if a triangle does not have a 90-degree angle. So the Q was the 90-degree angle part, but again, this is negated, does not have a 90-degree angle. So if not Q, then it is not a right triangle. And again, this is negated. So then not P. So not Q, then not P means that our statement is contrapositive. Again, pause as you need to. Go with me to slide 4. So on this slide, I'm going to ask you, we'll do this one together, and then I'm going to ask you to do a couple by yourself while you're trying them out. So if you eat all your vegetables, then you will grow. So the first thing we want to do is mark. So we're going to mark our P. If you eat all your vegetables, then you will grow. And then that's our Q. So remember, when we are doing our converse, I'm just going to write in a little note here for myself. Converse is Q, then P. Inverse was not P, then not Q. You should write this little note in for yourself. And then contrapositive was not Q, then not P. And so I'm going to type my statements because I think it'll be a little faster than me writing and probably a little easier to read. So for my first statement, whoops, let's try that again. I'm reversing my Q and my P. So my statement would be, if you grow, then, and you can change the verb tense, you ate all your vegetables. And you can change the size of this too, make it a little bit bigger so it's easier to read. So if you grow, then you ate all your vegetables. So once I've done that, I want to make sure, I'm going to check. So my green, my Q is if you grow. My P is then you ate all your vegetables. Let's try the inverse. This is not P, then not Q. So we're going to negate the first part of our statement. So if you did not, let's say do not eat all your vegetables, then you will not grow. And let's mark it. So again, we're going to start with P, but it's not P. If you do not eat all your vegetables, that's not P, then you will not grow. That's our not Q. So just checking to make sure that we're putting things in the right order. And then our last one, our contrapositive, is where we're negating, we reverse the statements and then we negate them. So going back to the original statement, if you do not grow, then you did not eat all your vegetables. And to mark those, so if you did not grow, that was our not Q. Then you did not eat all your vegetables. That was our not P. Go on to slide 5, and I want you to try this one. So you're going to label the P and the Q on here. Try that one. And then we will check it all together. So pause the video if you need to, and then unpause to check your work. I'm going to go ahead and do this now. So if you run in the hall, that is your P. Your Q is then you will get silent lunch. So again, as our reminder, let's put in the converse is reversing them, Q, then P. Inverse is negating the original statement, not P, then not Q. And contrapositive is negating and reversing, so not Q, then not P. So for your converse statement, you should have had, if you get silent lunch, then you ran in the hall. And marking that to check it, my Q is if you get silent lunch. My P is then you ran in the hall. My inverse is negating the P and the Q. If you do not run in the hall, then you will not get silent lunch. To mark my statements, so my not P is if you do not run in the hall. My not Q, then you will not get silent lunch. And my last one, my contrapositive, is where we switch them and we negate them. So if you do not get silent lunch, then you did not run in the hall. And to mark my statements again, or my parts of my statement, my first part, if you did not or do not get silent lunch, not Q, then you did not run in the hall, not P. So here's what I want you to do on your own. I would like for you to complete question 4 on the Jamboard. Then I want you to go on to slide 5, and there are 2 questions here. Label each statement as converse, inverse, or contrapositive, or none of the given conditional. So you have the original statement and then A, B, and C. Label them as converse, inverse, or contrapositive. On slide 8, I would like for you to write the converse, inverse, and contrapositive for the statement. If you do not work, then you will not get paid. There's one more slide. And this last slide talks about a counterexample. It says a counterexample shows that a statement is not always true. We've talked a little bit about this. Give a counterexample for each statement. So read the statement and give an example that would prove that the statement is not always true. When you've completed this Jamboard, please turn it into Google Classroom. The other thing that I want you to see in Google Classroom today, so I'm going to drag this down to show you. So on this assignment that we'll post to you tomorrow, or well, today, it's already posted to you. That's the logical reasoning Jamboard. I'm also going to add this video on there. It's just not on there yet. I want you to open up this assignment, also called Seat Geometry. This is looking at relationships with angles and triangles. And so this is also on a Jamboard. So this says connecting the legs of the chair at their midpoints as shown guarantees that the seat is parallel to the floor. I want you to think about relationships with triangles, and it's this type of specific chair where you can see that it's making triangles here, right? And it's connecting, they're saying it's connecting right here at the midpoint. It guarantees that the seat is parallel to the floor. I want you to think about what have you learned so far about triangles and their angle relationships and their side lengths and the lines, if there are parallel lines. What guarantees that this seat, this part, is parallel to the floor? Maybe draw it out as shapes. And this is just one problem here, but this is more like kind of like an IB task. So I want to see what you can come up with on this. So those are your things that you're going to be working on for today, for Friday. Make sure that you turn both of those things in. You do have until Monday to get them done, but I do want you to work during our class time today. If you have any questions, send me an email. I will have office hours on Monday from 3 to 4, so stop in there if you have questions also. And I hope that you all have a great weekend. I'll see you next week.